Greetings, and this is Cape Town Group 4's WeShare presentation. Our group consists of Diane Uwimana, Daniel Kruger, Lukhanyo Makwena, and myself, Siphesihle Shezi. Our WeShare project basically aimed to simplify expense sharing amongst friends, allowing our users to record expenses, request payments, and track settlements. Our biggest expectation was to track expenses. Furthermore, we allowed our users to log in with a valid email. We did not make use of two-factor authentication, we just kept it simple by allowing them to log in using a valid email, which is their Within Code email account. We then went forward with allowing our users to record their expenses, including the description, date, who they were receiving the money from or who they were sending the money to, etc. etc. With the payment requests, we allowed users to make requests to their friends. We can make use or give a case scenario where you're on a date with your friend and you unfortunately do not have enough cash at the moment. Your friend can then make a payment request so that you can pay them later at any particular due date that they have set. With the payments part, once a payment request has been sent, this section allows our users to keep record of who has made a payment from the request that they have sent or received. Now, getting into section A for research and data analysis. The technical tools that we made use of included Java, which was used for our backend. For example, it was used for authentication of the email, the authentication and validity of payment requests, the payment processing, and all of that. Anything that happened in the back end was mostly done in Java. Now, using the Javelin framework, we used it for building the web app itself. It was also used for the routing of the HTTP requests in line with JavaScript and also for the testing. We used a templating engine called TimeLeaf that we used to render the dynamic pages of our website. It was used to display data and user information. So any changes in the amount, should it be the request sent, request received, request payment itself, any changes in the page and username were then used or built using TimeLeaf itself. We also used the IDE IntelliJ for code, for writing our code, for editing our code, for testing our code. This is because it is efficient, functional, easy to use, and highly compatible with such designs and the project itself. We then used GitLab for version control. This helped us track our changes, host the project repository, and also for group collaboration. Even though these were solo projects, this tool itself kind of helps in that regard. Now, for our research tools, we made use of Stack Overflow, searching for solutions, especially with TimeLeaf, since it was a new concept to us in this project. We made use of the internet and curriculum site for instructions, finding tutorials, finding documentation, and examples working with this project. We also made use of AI tools for code reviews and bug detection. And that was all that was basically used in our research and data analysis. Now, for our time analysis, since we worked individually on these projects, it is quite impossible to make an estimate on how much time was made or used in each section. However, we were given 2 weeks for this iteration and we were able to complete it in that given time.
Good day, everyone. I am Lukhanyo Makwena. I'll be taking you through section B, cost benefit analysis. The purpose of this cost benefit analysis is to determine the resources, time, and expected benefits involved in developing WeShare. We want to understand what the project will require and how it will provide value to both users and developers. This cost benefit analysis will help us understand the main components that go into the WeShare project, including infrastructure cost, development cost, and testing cost. We also want to highlight the expected benefits, which includes an easy-to-use app for managing shared expenses amongst friends and an opportunity for us to gain hands-on experience with distributed systems. As already mentioned, breaking down the project cost, we've identified three main areas: infrastructure cost, development cost, and testing cost. For infrastructure, our main cost is hosting. Hosting makes WeShare accessible online, allowing users to log in, track expenses, and manage payments. Our hosting is estimated at 100 rands to 250 per hour based on available local providers. Since we are using SQLite, there are no database fees, keeping our infrastructure costs low. The largest expense is development, which involves front-end cost of 10,000 rands, back-end cost of 15,000 rand, and integration cost of 5,000 rands. We've estimated an overall of 30,000 rand for development based on project hours. This includes building the user interface, connecting to the database, and creating all the core features. For testing, we've allocated 3,250. Most of this is for in-house testing, covering Q&A and debugging, with some budget for optional external testers if needed. Testing ensures that the app is reliable and user-friendly, an essential step for the launch. For the WeShare project, we've broken down the time as needed for each major phase into hours to provide a clear estimate. Front-end development, which includes UI design and building user forms, is estimated at around 30 hours. Back-end development, which covers setup, server logic, and API creation, is estimated at 40 hours. This phase may run concurrently with the front-end development, essential for supporting the app's main functionalities. Testing and integration rely on both front-end and back-end completion. So it's important that these are stable before we move on to the next phase. Integration and testing is scheduled for around 20 hours. This phase ensures that the front end and back end work seamlessly together and involves identifying and fixing any bugs. To handle any unexpected delays, we've included 10 hours of buffer time as a safety margin. This buffer allows flexibility in case of unforeseen issues, such as debugging or delay in integration. Without this, any delay in one area could impact the entire project timeline. So having this extra time helps help helps us to stay on track. Overall, WeShare provides significant value for both users and for both value both for users and for us as developers. Our analysis covers the main project cost: infrastructure, development, and testing, with time estimates for each phase, front end to testing. We included buffer time to handle any unexpected delays, recognizing that dependencies between phases mean careful timing is essential for project succession. That will be all from me. Thank you.
Hello everyone, my name is Daniel Kruger, and I will be demonstrating this functionality of the WeShare expense tracker, as well as talk about its structure and how it works. Let's start with the layout of each page of our application. When you first reach our application, you're greeted with the login screen, where you must enter your email and password to log in. Upon logging into WeShare, you will arrive on the expenses dashboard, where you will have a comprehensive overview of all your previous expenses, as well as a navigation rail where you will find some links that allow you to access other features. Features like viewing any previous requests you may have sent, any previous requests you may have received, your expenses dashboard, and logging out. Now let me showcase the basic features and usage of the application. As you can see, we currently do not have any expenses made. To create an expense, simply click on the link labeled Add a New Expense. This will bring you to the New Expense page and this form where you will specify the description of your expense, the date it happened, and how much the amount was. As we submit our form, we are sent back to the expenses dashboard. And now we can see our expense we just made. We can see when it was made, we can see what it was for, how much money we spent, and we can see the payments request sent and the payments received, and then the whole net expense. Let's say you and a friend, let's call him Bob, went out for lunch and you ended up paying for both of you. You can create a payment request by simply clicking on the description of your expense, which will now take you to the payment request creation form. Here you can enter Bob's email address, the amount they owe you, and the date it has to be paid by. Once you have filled out the form, your new payment request will show up in a list. All payment requests for this expense will show up here, and you can view details about each request like who it is for, when it's due, how much, and if it's paid or not. So now that we created a payment request for our expense, let's go to our payment request sent page. On this page, you can see all of your previous payment requests across all your expenses. Currently, we only have one expense, so we only have one payment request for Bob. Now let's see how Bob can pay off his payment request. I will log in as Bob. All Bob has to do is go to the payment request received page. Here, we can see that Bob has indeed received a payment request. We can see the necessary details like who it is for, when it's due, how much, and the payment status. To pay a payment request, click on the Pay button. And just like that, Bob has paid his friend back, and we can see the payment status reflect positively. Now let's look at our expenses we made. Here, we can see that we have indeed requested this amount of payments, and that this amount has been received. And this is what our net expense comes up to after payments. So we originally spent 45, we received 25, so the whole net expense ended up to be 20. Lastly, I would like to showcase some of the HTML and styling behind this application. WeShare's web views are generated dynamically using TimeLeaf, a Java templating engine that can work in both web and non-web environments. Using TimeLeaf, we can create a main layout.html document along with many different templates. Each template gets populated with data and rendered on the server side, and then injected into the main layout, which then gets rendered in the browser. This means that these templates by themselves cannot be rendered. They serve as blueprints for TimeLeaf to build into the layout. So this is the main document, and then this will show on all pages. This is boilerplate. And then all the templates get injected into this layout fragment, contents. The main layout makes use of some semantic tags like nav and main. Some templates make use of section as well. We also make good use of tables to lay out our information on the page. As you can see in this document specifically, the expenses.html template. This contains a bunch of TimeLeaf tags and attributes and some arbitrary code that normal browsers can't execute. Therefore, this doc will not be rendered normally on its own. As for styling, WeShare styling remains a basic, inviting, user-friendly style throughout the user experience. The style targets tags instead of class names or IDs. This makes it easier to create a coherent look quickly and easily. That concludes the website demonstration. Thank you very much.
Good day, my name is Diane Uwimana. Welcome to our session on web development tools. In this presentation, we'll explore tools and resources essential for creating, designing, and managing websites. From HTML editors and design software to version control and testing tools, these resources streamline workflows, enhance collaboration, and improve user experience. Understanding these capabilities of each tool helps in building faster, more responsive, and user-friendly websites. So we're first going to talk about HTML editors and design tools. Our journey begins with HTML editors and design tools, vital for constructing and styling websites. Let's explore four primary categories. The first one being text editors, for example, Notepad, Sublime Text, and Atom. These lightweight editors are quick editors and for small projects. They offer syntax highlighting and basic code completion, making them suitable for beginners or developers working on simpler tasks. Integrated development environment IDEs. For example, Visual Studio Code, IntelliJ IDE, and Eclipse. IDEs are comprehensive tools featuring code completion, error detection, version control, integration, and debugging. They are designed for handling complex projects, but can be overwhelming for new users. Next, we have version control systems. These track and manage changes to code, facilitating collaboration in team environments. They enable developers to revert to previous versions, branch code for experimental features, and merge contributions seamlessly. And lastly, we have testing and debugging tools. For example, Chrome Dev Tools, Firebug, and JS Hint. These tools can assist in identifying and resolving errors, inspecting code behaviors, and testing responsiveness, ensuring that the site performs well across browsers and devices. Next, we can talk about the pros and cons of HTML editors and the design tools. Let's weigh the advantages and limitations of each tool category to help you choose the best fit for different scenarios. Firstly, for text editors, the pro is that they are lightweight, minimal, and straightforward, great for learning and small projects. The con for text editors is that they are limited functionality for layer complex projects lacking built-in testing tools and debugging capabilities. Next, IDE's pros is that they offer powerful tools like code completion, debugging, and library integration for efficient coding in complex projects. Cons for IDE is that they require significant system resources, a steep learning curve that can be intimidating for beginners. Version control tools pros is enable collaboration, version tracking, and easy rollback of code. Cons for version control system is branching, managing, and resolving conflict can be challenging for those new to the version control system. Then we have testing and debugging tools. Pros is that they allow real-time code inspection and ensure detection, helping improve user experience. And cons is that they may overlook back-end issues, often limited to front-end debugging without additional steps. The next slide, we talk about the important website file formats. Different file formats serve specific purposes in web development, influencing how content is structured, styled, and displayed. The case of HTML, they form the foundation of web pages, organizing text, links, images, and other elements. It ensures web content is structured and readable by browsers. Then for CSS, controls layout, fonts, colors, and spacing. CSS is crucial for achieving a cohesive and visually appealing design across pages. JavaScript adds dynamic elements like animations, form validation, and interactive buttons, enhancing user engagement. JSON, JavaScript, object-oriented, JSON, JavaScript object notation is a lightweight data format for exchanging information between the client and the server, commonly used in APIs. JPEG, PNG, and GIF, these are image formats, each optimized for different purposes. In the case of JPEG, they are ideal for compressing photos. PNG maintains quality with transparency support. GIFs support simple animations. XML, often used for data configuring and document storage, more verbose than JSON, but ideal for hierarchical data. Next, we talk about the role of web browser plugins. Browser plugins expand the capabilities of browsers beyond simple page rendering. They fulfill various functions, including functionality extension. This adds features like PDF viewing, ad blocking, or automatic form filling. Security enhancement boosts browser security with tools like VPNs and anti-malware plugins to protect data and privacy. Then we have user experience customization, which allows user to tailor browser appearance, enabling for dark mode, custom themes, or tab management. And then we also have performance optimization, allows users to tailor browser appearance, allows users to improve page loading and resource usage, beneficial for users on lower networks. Then we have accessibility support, which assists users with disabilities by adding features like screen reader and keyboard navigation. Also, we have legacy technology support, which helps users access older web technologies, ensuring capability across different platforms. Next, we speak about major plugin types available. Let's take a closer look at the major categories of browser plugins available. Multimedia plugins. It ensures audio and video playback. Examples include Adobe Flash Player, now obsolete in HTML5, media plugins for modern websites. Security plugins focus on protection by blocking malware, encrypting data, and offering VPN support. Popular examples include uBlank, Origin, and HTTP Everywhere. Productivity plugins assist with task management, calendar integration, and project tracking. Tools like Trello, Asana plugins streamline workflow directly in the browser. Privacy plugins protect users by preventing tracking and blocking ads. Example, Privacy Badger and DuckDuckGo Privacy Essentials. And then developer tools used for debugging and analyzing website performance, such as Chrome DevTools or React Developer Tools. Accessibility plugins aid users with disabilities by adding screen readers, text magnifiers, or speech recognition. Examples: Web Disability Simulator and Color Blinding. Customization plugins allow personalization, like themes for tab manager to improve browser experience. Examples include Stylish for custom themes and Tab for managing open tabs. So just to conclude, the world of web development is broad, encompassing tools for creating, editing, testing, and enhancing user experience. By leveraging the right combination of tools, from editors to plugins, developers can achieve high standards of functionality, security, and accessibility. Whether you're a beginner or an advanced developer, understanding the tools' strengths and limitations will help you make better choices and build impactful websites. Thank you for your attention, and I hope this guide is deepened by your understanding of essential websites of development tools. Thank you.